Here's a fact that will break your brain. Electricity wasn't invented, it was discovered, or rather, rediscovered, because humans knew about it thousands of years before Edison and the light bulb. Ancient Greeks knew that if you rub amber against wool, it starts attracting small objects. In 200 BC in Mesopotamia, they used what modern archaeologists call the Baghdad battery, a clay jar with copper and iron inside that produced electric current. 2,000 years ago, a battery. Now imagine the Stone Age. No wires, no outlets, but everything necessary to make electricity and create light is lying right there on the ground. First, what is electricity actually? Everything around you is made of atoms. Inside each atom, there's a nucleus and electrons flying around it. Particles with negative charge. Usually they stay in place, but you can knock them loose, pull them from one material to another. When billions of electrons flow simultaneously, that's electric current. That's it. Electricity is moving electrons. Now, how to make them move. Method 1. Static electricity. Take amber. It's fossilized tree resin, found everywhere ancient conifer forests grew. Stone Age people found amber constantly. Rub amber against fur. Fast. Hard. What happens? You're physically stripping electrons off the fur and transferring them to the amber. The amber becomes charged. Hold it near a feather. It sticks. Hold your finger close in darkness. A tiny spark jumps. You just created lightning, very small lightning. Ancient Greeks described this 600 years BC. Problem: this is useless. The charge lasts seconds. Not enough energy for anything practical. Need something stronger. Method 2. Chemical battery. Iraq. Archaeologists find a clay jar. Inside is a copper cylinder. Inside the copper is an iron rod. The iron doesn't touch the copper. Insulated with bitumen. Dating: 200 BC. When scientists recreated it and poured in vinegar, it produced current. Weak. Less than a volt, but measurable. How it works. Two different metals in acid create a potential difference. Electrons want to flow from one to the other. Connect them with wire. They flow. Copper and iron, vinegar, clay jar, all available in the Stone Age. Copper occurs naturally as pure metal. Nuggets lying on the ground. At a settlement called Çatalhöyük, dated 9,000 years old, they found copper jewelry. People worked copper in the literal Stone Age. Iron is harder, but there's a way. Meteorites. Many meteorites contain nearly pure iron. People found them and made tools long before metallurgy existed. In King Tut's tomb, they found a dagger made from meteorite iron. Vinegar is fermented juice. Leave apple juice in air. Wild yeast turns it to alcohol. Then bacteria turn alcohol to vinegar automatically. People made vinegar accidentally for thousands of years. Clay jar, copper cylinder, iron rod, vinegar inside, battery complete. But here's the problem. One battery gives less than a volt. Not enough to do anything. Solution? Multiple batteries in series. Connect copper from battery 1 to iron from battery 2. Iron from 2 to copper from 3. The voltages add up. 5 batteries, 5 volts. 10 volts. Ancient people might not know the physics, but they could notice that several jars connected together give a stronger shock than one. Now you have electricity with sufficient power. Time to make something glow. The light bulb. Here's what you need to understand about light. When you heat something, atoms vibrate faster. The hotter it gets, the faster they vibrate. At a certain temperature, the material starts glowing. First red, then orange, then white. This is called incandescence. Red-hot iron glows, red-hot coal glows, red-hot wire glows. Edison's bulb worked like this. Electric current passed through a thin carbon filament. The filament heated to 4,500 degrees Fahrenheit, started glowing bright white. Problem? The filament burns up in seconds if oxygen is present. That's why a bulb is a glass sphere with vacuum inside. Without oxygen, the filament doesn't burn, just glows. Creating vacuum is impossible in the Stone Age, but there's a workaround. Take thin plant fiber, bamboo, dried grass, thin twig, char it over fire without air access. Bury it in hot ash. You get a carbon filament, thin, fragile, but carbon conducts electricity and withstands high temperature. You need a glass bulb. Glass is made from sand melted at 3,000 degrees Fahrenheit. In the Stone Age, you can reach this temperature. A very hot charcoal fire in a pit with good airflow. That's how first glass was made accidentally. Fires on sand sometimes melted it into glass. Form a glass bulb, place the carbon filament inside. The ends of the filament come out through the bottom. Seal with clay or resin. Not perfect, but as tight as possible. Connect the filament ends to your battery of 10 jars in series. Current flows through the thin carbon filament. The filament heats up, starts glowing red, then orange, then a dim yellowish light. It will last a few minutes, maybe an hour if you got lucky with the seal. The oxygen inside the bulb slowly burns the filament. Without vacuum, this is inevitable. But those few minutes, light without fire, light from electricity, in the Stone Age, you sit in the cave, darkness all around. The fire has died. A glass bulb on the stone in front of you glows with dim yellow light. Not bright, about as bright as a candle, but no flame, no smoke, just light. The cavemen stand around, staring. Nobody moves. One reaches toward the bulb, checking where the fire is. There's no fire. The bulb is warm, but no burning. Another looks at the jars connected with wires, at the glass bulb, at the glowing filament inside, slowly starting to understand the connection. The filament gradually dims. After 10 minutes, goes dark completely. But those 10 minutes changed everything because they just saw the future. Any sufficiently advanced technology is indistinguishable from magic until someone shows you how it works.